Good morning, everyone. My name is Gary Sealing. I do development work on AWS for Element 84. Our next talk is by Keith Gregory, the AWS practice lead for Chariot Solutions. And he'll be talking about how to use transient AWS accounts to manage costs and prevent abuse by external entities. I'm looking forward to seeing this talk because I've worked with Keith before and he's deeply knowledgeable, and every time he presents, I learn something new. I'd like to thank everyone for being flexible and making this a great online conference. And just like the other talks, we'll be taking questions through Slack and the Zoom chat, and I will moderate those for Keith at the end. All right, take it away.
All right. Well, good morning, everyone, and welcome to my dining room. So this talk is about cloud ops, but it's really about developer enablement. And to start and understand the developer enablement, I want to focus on the we part of the subtitle. And we are Chariot Solutions. We're an application development consulting firm in Fort Washington, but that's not all we do. We also created and host a conference called Emerging Technologies for the Enterprise, which you may have heard of. We also do training and developer workshops, and lastly, we're an AWS consulting partner. And those last two kind of mix together and were the genesis of this talk, trying to figure out how to reduce friction when we're giving a workshop. And this started out, we did an IoT workshop last fall for about 40 attendees. And the question is, what do we do with accounts? And if you've ever gone to a meetup, for example, where there's an AWS person talking or doing a walkthrough, generally you have to bring your own account. Well, that's a problem because number one, a lot of people don't have their own personal AWS accounts. And if they use corporate accounts, they may not be allowed to use those corporate accounts outside of corporate business. The other option is you could create an account while you're doing the workshop, but this takes time and a lot of people are quite reasonably concerned about putting their credit card in and creating an account that they may never use again. After doing this for the workshop, we also found it became a very useful thing to support our project teams, which is why you might want to do this. So I think one of the great promises of the cloud is that it allows developers and teams space to experiment. And I think back 20 years ago, if you wanted to set up an environment outside of your main production or QA environments, you'd have to scrounge around the office, find old PCs, hook them up to a router that you bought at Staples that morning, and you might spend 3 or 4 days configuring these things just to do an hour or 2-hour experiment. And the cloud just kind of takes away that friction. You need a dozen machines, you fire them up, 15 minutes later, you're ready to go. The problem with doing that, of course, is that if you do that in an existing business environment, you might step on other people's toes. So having a sandbox account where you can freely experiment, bring things up, shut things down, is a huge benefit for developers. It also, sandboxes versus giving your developers their own credit cards and saying go off and create accounts, centralizes control and billing of the account. So you know what's happening so that you don't see big bills at the end of the month. The other thing that I think it helps with is its practice for managing and promoting workloads. Everybody uses DevOps tools or should be using DevOps tools these days where you write your scripts to bring up your environment, to deploy your software. It's kind of a good habit to work through those scripts, again, in a place where you're really not going to affect anybody else. So, for our workshop, we looked at a couple of different approaches. One is to have a single AWS account that would be segregated somehow. And this worked really well for us before that for our internal training, where we might have a half dozen to a dozen people. And you all log into the same account and you just have rules over how you name things so that you don't get in everybody's way. The trouble is, especially for this workshop, which was an IoT workshop, some of the services that we needed were either account-wide or, in the case of IoT Core, specific to a region. There was only one IoT Core endpoint for each region, each account. So you really couldn't have a situation where 40 people are sharing the same account. Other idea, manually create and manage independent accounts. We rejected this pretty quickly because, again, we want to centralize the control and billing of these accounts. So the two that were kind of viable solutions, one was to manually create and manage accounts within an organization, and the other was to use AWS Control Tower / Landing Zone, uh, which is Amazon's solution for creating accounts. We ended up with creating the accounts within the organization, so I'm going to talk about those parts a little bit. But first, the goals. Number one, limit the likelihood of big bills. Everybody's concerned about Amazon billing. It is easy to run up a big bill without understanding it. So a big part of setting up any sandbox environment is putting the controls in place to avoid that. Certainly identify who is responsible for creating things. One of the worst things that you can have if you're managing an AWS deployment is to come across an EC2 instance that's been running for 6 months and has a intriguing name such as ETE support. We had one of those, and no hint of who created it and whether it's still needed. And then finally, we want to automate as much as possible. Okay, so let's say that you want to do a similar sandbox organization. How do you go about setting it up? The first thing, again, Amazon has Control Tower and Landing Zone, which is their solution really for multi-accounts. And they have, once you set it up, you have an account factory that will let you create child accounts on demand. You have predefined guardrails to prevent those accounts from doing things that might run up big bills or otherwise cause damage. And you also have separate accounts that are destinations for application and audit logs that are essentially write once, so that for a production deployment, you don't have to worry about someone getting in, causing problems, and then erasing the logs. The problem with Control Tower, aside from the fact that it was relatively new when we first started looking at this, is that it's kind of heavyweight. It's designed for long-lived child accounts. So you might use Control Tower to create sets of accounts for each of your applications that you deploy. And by sets of accounts, I'm thinking the dev, QA, prod. We're looking at accounts for developer sandboxes that might be in use for a month, 2 months. In the case of a workshop, it might need to be reconfigured for a one-day workshop. So for us, it was really too heavyweight. And I was actually very interested to hear, I had attended a session at reInvent this past year where the Amazon team that is responsible for setting up workshop accounts came to the same conclusion. So again, depends on what you need. Good solution for long-lived accounts, probably not for the kind of short-lived sandbox accounts. So we ended up with AWS Organizations, which is a service that's been around for, I think, 3 years now. And prior to Organizations, a lot of companies had gone down the path of creating 3 separate AWS accounts for dev, QA, and prod, and potentially other accounts as well. And Organizations allows you to pull all of those accounts into one organization and make a hierarchy of accounts. So we'll see a hierarchy in the next slide. The accounts can be either invited or created. And I think the only reason to invite an account is you already have the account created. Again, you're one of these companies that had set up the dev, QA, prod. Normally, you want to create a new account within the organization. And for the sandbox, that's the approach that I'm going to be showing. A couple things to remember: each child account needs a unique email address. I put this in because I made the mistake once of trying to create an organization, my first organization, and give all the child accounts the same email address. And that put me in a state where I had multiple child accounts. It let me try to create them, but they failed to create, they limited, and they couldn't be deleted. I had to send a ticket to Amazon support. One little tip here is if you're used to Gmail, you know you can have your base email address and then put a plus something on the end. So like Gregory plus ete mailings@gmail.com. And now you know if that email address is used somewhere else that the original company shared your information. Well, for creating child accounts for Amazon, it's great. You can have AWS plus Sandbox 1, AWS plus Sandbox 2, and so on. And still have everything coming to a single email account. And I know Gmail supports that and G Suite. I know the email provider for my personal domain supports it. I'm assuming that pretty much everybody does now. The other tip that I don't show here is when you create email addresses for an AWS account, make sure that they're group addresses. Have a bunch of people who receive the emails. Sometimes that gets annoying. AWS sends out email blasts. Over the last month, we've got 50 or 60 warnings of changes to permissions that are going to happen a year from now. But you don't want to be in the position where you need to contact AWS support, you need to interact with an email address, and the one person whose email address is on the account is on vacation. The other thing that you're going to need to do is increase your account limit. When you create a new organization, by default, you're only allowed 4 accounts, which is, I think, the master, dev, QA, and prod. Amazon is fine with upping that for you, with the one caveat that you can't increase your limits on a brand new account. They want to make sure that you've had a history with them before they'll do it. So here's a picture from the console of our organization, and I'd skipped over the point of organizational units in the previous slide. Our Chariot organization is fairly straightforward. We have a root for the organization, which is our master account and our production account, and we have one organizational unit for sandboxes and one organizational unit for workshops. And the idea is that you put accounts into the organizational units and then can apply policies to the entire organizational unit. Okay, so let's start off creating a child account. Really simple. Easiest to do it from the command line, create an account within an organization, giving it a unique email address. If you want to create 20 accounts, you paste that in 20 times. Nothing to it. The real question comes with how you manage your users in these accounts. And as I see, there are a number of different options, but as I see it, there are 3 main options. Option number 1 is you create IAM or Amazon AWS users in each child account. And that's really easy for your users because they only have one login, they get directly into the account, no problem. If they have multiple accounts, that becomes really painful. Option number 2 is you create your IAM users in the parent account. Don't really give them permissions in the parent account other than the ability to assume a role into a child account. And this I've found to be a lot better if you have lots of accounts that you're bouncing around through. And anecdotally, everybody that I've introduced this to is very happy with it. The third option is probably more applicable to a larger organization, and that's AWS single sign-on. And single sign-on uses an existing Active Directory server to manage your users. And it also allows you to create a server inside of itself. But this works really well if you're in an organization that already uses Active Directory for credential management, because now people can just log into the single sign-on portal using their normal user credentials and then pick an account that they want to switch into. So it becomes a lot easier for users and has another big benefit I'll talk about in a little bit. It is a little bit more complex. So you have an Active Directory user is part of an Active Directory group, which is associated with a single sign-on permission set, which ultimately turns into an IAM role that you assume in the child account. For a small organization, I think option number 2 is more scriptable, but certainly it's nice to have a single password across your company. And one thing is always use multi-factor auth, right? So Amazon accounts, a weak or leaked password can result in a big bill. You don't want to do that. Multi-factor auth is you have your password, something you know, and you also have a token, a 6-digit cryptographic token, which is something you have physically. And a couple of options for Amazon. There's the Google Authenticator or Authy using a virtual one-time pad, time-based one-time pad. You can have a physical key. I think they only support Gemalto. All of us had the RSA keys 10 years ago. I don't think Amazon supports that. Or you have a physical YubiKey that you plug into your PC to provide the additional authentication. Again, the goal here is to prevent unauthorized access. All right, once you create the account, inside that account you have the organization account access role, which is a long name, but it is the name that Amazon uses. And this is basically a role, IAM role, in your child account that has administrator privileges. And it's really useful if you're the person responsible for these accounts, that now you don't have to log into the individual accounts. You just switch into the administrator role in the particular account. It's also really useful for sandboxes that's the role your user uses. In a sandbox, generally your users are going to be admin. Controls on them are applied from outside of the account. However, with this single role, clearly you don't want anything to happen to it. Otherwise, you have to log in as the root user on the account. And that brings us to guardrails. Now, if you're not familiar with the term, a guardrail is that metal barrier along the side of a road that prevents you from driving off the road over a cliff and into a river. And I say if you're familiar with it because when I moved to Pennsylvania, I learned that here they're called guide rails, as in they guide you along the road, which personally I think is entirely the wrong message to send. So Amazon uses the term guardrails. What they really mean are service control policies. And a service control policy is an IAM-like policy that limits what a child account can do. It's an IAM-like policy because it's not managed inside the IAM part of the Amazon ecosystem. It's managed in the organizations part. It's also not doing the same thing. IAM policies grant permissions within an account. Service control policies limit the ability of an account to do something. So you could be an administrator within an account. You could even be the root user of the account, the child account. But if the service control policy says you can't start an EC2 instance, you can't do it. So let's look, so there's two types of service control policies, allow versus deny. And it seems pretty straightforward, right? Allow lets you do something, deny prevents it. It's how these interact. So an example service control policy might be allowed to allow all EC2 actions. And if that was the only service control policy that you put on a child account, well, first of all, you couldn't log into the child account, but let's say you also add in login permissions. You could start up an EC2 instance, shut it down, but you couldn't start up an RDS instance because it's not explicitly allowed. For a workshop type environment, crafting explicit allow policies is a good idea. For a sandbox environment, you probably want to do an allow all policy, a basic service control policy that allows any action, and then attach additional policies that will deny actions. And we'll see a couple of those. One thing to be aware of is that allow policies can be applied to single accounts, can be applied to organizational units, only affect the accounts in that organizational unit, whereas a deny can apply to all descendants of an organizational unit, which is a real problem if you put a deny policy at the root of your organization. I'm going to assume that Amazon support can undo that for you, but basically you lock yourself out of your account. Okay, so let's dive into a service control policy. And I have three that I want to talk about, which is three general ideas of policies that you would want to use. And as I said, this is an IAM-like policy. It's using the same policy structure as an IAM policy. So IAM policies have an effect. In this case, we're going to deny. They have one or more actions. In this case, we're going to deny any actions that update a role. And then they specify resources. And in this, we're protecting the organization account access role. Now, a really key difference between service control policies and IAM policies is the use of wildcards. In an IAM policy, you almost never want to have a wildcard because a wildcard says that that IAM policy is going to have very broad-ranging effects. With service control policies, it's the exact opposite. I could list all of my accounts here and individually specify the ARN for the organization access role. But if I did that and added in a new account, now that access role wouldn't be protected for the new account. So I simply use a wildcard for the account portion of the ARN. And now I know that whatever account I add into an OU organizational unit that has this SCP attached, it's going to be protected. And we attach this SCP to both our workshop accounts and our sandbox accounts. The next one, this applies more to a sandbox account, is to restrict regions. As I said at the beginning, we're based in Pennsylvania. There's very rarely a reason for someone using one of our sandbox accounts to fire up anything in, say, Tokyo region or any of the EU regions. So this is a policy that is a deny everything, all actions, all resources, but then it looks into the request and applies a condition. And the condition looks for a requested region field in the request, and if it's not one of those four values, US East 1 and 2, US West 1 and 2, the action's denied. Okay, there's some requests that are going to come in, such as IAM requests, that don't have a region. This particular policy doesn't apply to them. The last type of SCP that I want to talk about, excuse me, is putting limits on the resources that people can create. So again, it's easy to run up big bills. I think the most expensive EC2 instance is somewhere in the $12 an hour range if you fire it up. For most sandboxy tasks, you don't need to do that. So we put a policy that looks at EC2, won't let you do a run instance unless it's a T2, T3, or an M5 large. And all of these instance types will cost less than 10 cents an hour to run. So it's a reasonable charge. It's not going to run up a huge charge. This is a case, well, there are two things to think about. The number one thing to think about with this is just how granular you want to get. So M5 large, or more particularly M5D large, which has an attached SSD, I find to be a useful instance type for a build machine. But Amazon, at some point in the last year or two, released the M5A series, which is using an AMD processor instead of an Intel processor. So you can get really complex in this. Realistically, just throw out a few things that work. The other important thing to note is this is just EC2. We also have in our limits SCP, we also limit the type of RDS instances, Elasticache, Elasticsearch, and probably a few others that I can't remember since I put this together a year ago. Okay, so those are the ideas of some very basic configuration that you really need to do to protect your organization, yet still, again, the key is enabling your developers. Next up is when you turn those developers loose. And the very first thing is to have a talk about security. So I'm a developer. I think about security because I've tried to train myself to do that. But in general, your goal as a developer is to get something done, not necessarily protect it. You as the person who is managing the organization, your primary goal is to protect the organization. And if you have to get in the way of the developers, that's necessary. There is a meeting place. Try to convince your developers to understand basic security. So one place to start is the AWS shared responsibility model. And this appears in a lot of AWS documentation. It's a diagram that compares the security of the cloud to security in the cloud. And I think the easiest way to understand that is a security group. Amazon is responsible for the security of the cloud. They are making a guarantee to you that if you use a security group, there's no way that anyone's going to be able to defeat that security group. On the other hand, you are responsible for security in the cloud. You're responsible for ensuring that your security group doesn't open up SSH permission to the world and is used on an EC2 instance that has a weak password for a login. Of course, long random passwords, multi-factor auth, and I put this in more because of the next issue, which is access keys. So if you're just using the console, multi-factor auth is great and a random password, but most people use AWS access keys, which are required to run the command line programs or to use the SDK if you're writing a program to access AWS. And access keys are passwords. If someone gets them, they have all the access that your account has. So, to quote Gandalf, keep them secret, keep them safe, don't ever check them into source control, which seems obvious, but a lot of people do it. Enough people do it that if I recall correctly, GitHub has started a bot that analyzes your commits to make sure they don't include access keys. One thing with access keys is if you use assumed roles, and that includes single sign-on, they're less vulnerable because when you're assuming a role, you get access keys that are limited duration. So by default 1 hour, but up to 12 hours. So if you do accidentally leak those access keys, the window of vulnerability is fairly short. The last thing I want to talk about is something that not many people think about, but random AMIs. So AMIs are Amazon Machine Images. They're the operating system that you use to start an EC2 instance. And Amazon provides you with a whole bunch of AMIs out of the gate that are official Amazon AMIs using the Amazon Linux distro, using various versions of Microsoft Windows Server, Ubuntu, and there are a few others. I think they still have AMIs that include pre-installed software. Third-party providers also create AMIs. So for example, OpenVPN has pre-configured an Amazon image to run the OpenVPN software. And they place those in the marketplace, and you pay a certain amount extra per hour that you run the EC2 instance. And it's great for companies that want to basically make service revenue. It's great for users who don't have to understand the details of configuration for a lot of this software, but it's also a great chance for scammers. So one of the AMIs that people in the corporate world use a lot is CentOS. And if you go out and just search for CentOS in the Amazon marketplace, you'll find that CentOS themselves has an official image, and you'll find a lot of images that just arbitrary people have uploaded with a CentOS distribution. Most of them probably safe, some of them possibly loaded with malware, and some of them loaded with a per hour charge that will quickly give you a very large bill. Okay, so once you've gotten past the talk about security, talk about tagging your resources. Everything you create in Amazon can have tags, which are name value pairs that give information about it. And for people bringing things up by hand, I really think start with a simple strategy. Say, look, you bring up an EC2 instance, put a created by tag that's your username, put a delete after tag, which is a simple date, 2020-04-15, that says, don't delete this before now. Now, if you come through a month later and see that, should have been deleted 3 weeks ago, you can feel safe to do it. A lot of companies go past the simple strategy and have lambdas that start looking for missing tags and either send notification to the users or just go and delete. I attended a talk a few years ago with someone who had implemented a lambda that if you created an EC2 instance with an open security group, it would terminate it. And that would happen within 5 minutes after you starting it up. Turns out this is actually a fairly complex task. I've been thinking about a blog post for Chariot of all the different pieces that you need to do this. As the person responsible for controlling costs, Cost Explorer is going to be your new best friend. If you're not familiar with this, it's available from the billing dashboard drop down on the console. And historically, you could turn on cost reports, which were CSV files. I think they were generated every day that had extremely detailed information about where you were spending money. And to be able to use them effectively, you had to load them up into a business intelligence tool so that you could slice and dice them. Cost Explorer is that business intelligence tool. You can filter the records. So in this case, I've filtered by just our workshop accounts. And you can group them by different things, and this I've grouped them by service and restrict the date range. So this particular output shows one of our workshops on November 6th. It was, I think, a 2-hour workshop, heavily used Kinesis Analytics. And then, as you can see, the days after the workshop, no charges. This is a good picture. Towards the end, we're going to see a not so good picture. The other side of this, especially with sandboxes, is AWS budgets. So you set up a budget, and it's basically a notification that you can apply different accounts, use either current charges or forecasted charges, and send emails. So for our sandbox accounts, we have a budget of $250 for all of our sandboxes. And we send an email if the forecasted amount is going to be more than 50% over that, so $375. Just so that we know what's happening, you see that email, you're going to start saying, okay, I better look, make sure nobody's doing something, or at least understand what they're doing. Sometimes you can get that forecasted email on the 3rd day of the month, which is a bit of a problem because then the account may not actually go over the budget. But it's a good warning. It's something to pay attention to. And the final thing for management is CloudTrail. CloudTrail is an audit log for API calls. By default, it will log the API calls that actually change your environment, such as create role or run EC2 instance. For an extra charge, you can have it to the detailed of it will log every single one of your Lambda invocations, every access to an S3 bucket. So in security conscious organizations, you want to do that. The problem with CloudTrail is that it's logging the actual parameters that were sent to the AWS API. And it can be really challenging to pull out what you need to know from that. Some parameters are pretty constant. So, for example, everything has an event name because it's an API call. But things as simple as user identity vary depending on whether you're directly logged into an account using an assumed role, or it's actually a service doing something on your behalf. So I find it really useful, and I wrote a blog post on this for Chariot, to take the output of CloudTrail and dump it into Elasticsearch, and then you can use Kibana to explore that data. So this is an example of someone started up a EC2 instance and didn't tag it, and let's find out who it is. So it's really quick to go in, put a filter. I just care about the run instances API call, and I have a fairly standard show me what account and who started it up, and then I paste it into the search box, the EC2 instance ID, and I found out that, oh, it was me. Okay, I guess I better shut that down. All right. This next section is going to focus on if you are actually running a workshop. And you may think, we're never going to do that. We're not a consulting firm. But you may find it actually very useful to set up a hackathon internally or do training internally and basically create a bunch of accounts so that people have their individual spaces to work. Or you may be running a workshop for someone else, in which case there are a couple of phases. The first phase is getting ready for your workshop. And this is a case where the service control policy should explicitly allow only the services that the workshop needs. If you don't need to start EC2 instance, don't give them an allow all policy, and remember to block EC2 instances. Just give them an explicit allow on EC2. And a little hint, test run the workshop, make sure you've got all the permissions right, unless your permissions expert is on hand to look over people's shoulders and figure out what's missing. I think workshops are a case where a single user per account works really well. You just randomly generate the password, excuse me, for that user. And then once you've got your workshop environment set up, put a deny all service control policy on until you're ready to run it. Don't let people get in and muck with it and end up with something with an unstable environment for a workshop. You're going to do your workshop. Wrapping up, you want to start, everybody leaves, before you leave, before you tear down, put on an SCP that prevents creating new resources. And then have scripts in hand, and we've got some that may end up being a GitHub example, to delete all of the resources that were created. And this is definitely something that you want to do as soon as possible. You don't want to leave your accounts where people can still log into them. And if they're running something with a per hour charge, you don't want to leave that running up your bill. And then finally, once you've done that, and it runs pretty quickly, put on a deny all SCP so that, again, the workshop accounts don't get messed up. Something that I found, Excel, or in my case OpenOffice, is a really great tool for this. So multi-sheet spreadsheets, the first sheet has the account numbers and a randomly generated list of passwords. And yeah, this isn't terribly secure, but again, we're denying all access until the day of the workshop. And then we have subsequent sheets, which are all the command line programs, for example, to enable login on the account. That it's based off the values in the initial sheet. You just copy and paste into your terminal window, and it's automation. It's not automation of the scale of CloudFormation or Terraform, but it is automation. And then I hinted at this earlier, Cost Explorer really is your friend. So this was a workshop that was run on a Thursday, I think, and the person running it had to catch a plane and did not run the scripts to clear everything out on that Thursday. And as you can see, the per day charge for Kinesis is over $150. And what happened is one of the workshop attendees, for whatever reason, created a Kinesis stream with 500 shards. Now, to support the workshop, you only need one shard. To support most real-world use cases, you only need one shard. And one shard is incredibly cheap. 500 shards running over the weekend, not so much. This is the sort of thing that I originally had a slide in saying, well, this could be controlled with a service control policy, but it can be really hard to think of all those policies. Our policy now limits the number of shards you can create. But again, the key here, you want to enable your developers, but you also need to pay attention. And that pretty much wraps up what I brought to talk about. So I'll turn it back to Gary to read off any of the questions.
All right, I'll give people a couple of minutes to post some questions. While you were talking, Keith, I tracked down the blog post that you had about indexing your CloudTrail logs, because that looked like that would be useful to me. So first question, is there anything akin to a circuit breaker or kill switch for cost overruns?
Not that I know of. So my understanding of budgets is that they go through the CloudWatch metrics alarms so that you could set up a CloudWatch metric. And I have not done this, so I may be completely telling falsehoods here. I believe you can set up a CloudWatch metric that could then trigger a Lambda to be able to look into the alarm and shut down. But generally, I think the kill switches are more manual. And again, the goal here is when you get that email from AWS budgets, talk to your people. Understand what they're doing. They might have perfectly valid reasons for doing things that are expensive.
I'll add one question I had. Do you know what options there are for listing what is in your AWS accounts? Like, is it just a combination of guard duty and the bill?
Yeah, there are a number of open source projects, and I can't think of them offhand. For some reason, AWS Nuke jumps to mind, that are all about going through your accounts and seeing what's running there.
Hmm.
And the scripts that we have to clean up after workshops do a little bit of that as well. But no, things, yeah, most of AWS is, I think, focused towards production deployments where you use things like AWS config to really keep track of, or
Yeah,
AWS systems manager to keep track of what you're deploying.
yeah, that makes sense. All right, this question from Martin Snyder. Aside from stealing keys that are mistakenly revealed and sneaking, quote, bad things into an AMI, what other attacks are out there?
You know, they're infinite. Um, so they're infinite, but to a large extent avoidable. So again, credentials are the big ones that developers control. Having a bad AMI, or you know, even if you don't use AMIs, if you're using containers, I know if you Google for security flaws in public Docker containers, you're going to be a little bit scared. But it's your standard security, such as Tomcat, making sure that Tomcat is up to date, isn't using any of the libraries. I don't know if you remember a few years ago, there was the Apache Commons remote code execution flaw. It's things like that. And to a very large extent, Amazon can help you with that. So, for example, you might be worried leaving your web server directly open to the internet. So that may or may not be valid, but put an ALB in front of it, a load balancer. Now you have that level of isolation. Um, but again, that level is the area where security experts come in and audit, and I do not claim to be a security expert.
Sure. Do you have any tips for protecting your uh, preventing developers from checking in to get credentials?
Well, again, there is, it's either GitHub or Amazon scans commits. There's probably an open source project, but again, I like the idea of having the limited scope credentials that you get from either assuming a role or using single sign-on, that if they check in credentials accidentally, those credentials really can't be used to cause damage.
Sure. What resources would you recommend for learning how to do AWS administration?
No substitute for experience, but one thing, they're long and fairly dry, but the AWS well-architected white papers give you a really good sense of what's out there and how you would put together the administration.
Are there penetration test services that can reliably test your AWS setup that you know
Oh,
of?
I do not know of any specific names. I do know, however, that you are supposed to talk with AWS before performing a penetration test.
Yeah.
They want to know that you're going to do.
Do you recommend ad hoc ephemeral accounts for the in-house developer use case or a long-running dedicated accounts?
So ephemeral is more about the usage of the account in my mind, that the account is going to be used for a day or a month or 3 months. And it's how you configure the account and what restrictions you place on the account. So yes, we have, as you saw in one of the earlier slides, about a dozen sandbox accounts that get assigned to individual developers or to project teams. In fact, I've been working closely on one project where that's just a huge use for us, is all of the development happens in an account that we control, and we've granted the client access to that account, read-only access, so they can keep track of what's happening. And it just smoothed out uh, a whole lot of organizational work for them to allow us access to the account. And of course, have to be very careful about what data you can't have. Certainly, you can't have protected data stored in such an account. You want the client to be responsible for that. But yeah, I look at that as an ephemeral account. We've been working on this project for 3 months so far, I think, 2 months maybe, and we're going to be working on the project for another month to 3 months. So once we're done with that, everything gets wiped out, and that same physical account can be assigned to another project team. I hope that answered the question.
Sure. Do you have any, so as someone who has many AWS accounts, do you have any tips for managing the developer experience of that side of switching between those accounts?
So I do a remarkable amount in the console. Um, and yeah, the console helps because it will keep track of at least 5 accounts that you can switch between. For the command line, I also have a little utility on my personal GitHub that will assume a role into an arbitrary account. So if you know the role, it's basically a Python script that starts up a new shell pre-configured with role credentials. Um, if you have a lot of accounts that you're bouncing between, I'm going to come back to single sign-on and logging into the single sign-on portal and then switching to selecting an account from that. I've actually, as I've been working on this talk more and more, I've become more of a fan of single sign-on.
Cool. All right, I think that might be it for all the questions we have. Thanks, Keith, for speaking, and thanks everyone for joining in today.
Okay, I do have 2 more slides.
Oh,
Um,
sorry.
that's okay. There's the About Me slide, and this will be available on the when we upload the slides and also the videos. Basically, if you see KD Gregory on the internet, it's either me or a person who I think used to be a reporter at the Philly City paper. And then finally, one of the weird things about kind of talking into my screen about this is the lack of audience interaction. So I decided to take that into my own hands.
There we go.
All right, thank you all for listening in.